For this problem, let's take a look at the slope of the tangent line of r is equal to sine 2 theta at theta is equal to pi over 6. So said another way, so pi over 6 is basically this direction here. So here's 0, here's pi over 2, pi over 4 is halfway in between. So pi over 6 is something like this. And that would take us to this point on the tangent line, this point on the curve roughly. And so the question is, what is the slope of the tangent line at this point? Okay, now to be able to do this problem, we use the formula for the slope of a tangent line for a polar curve. So dy dx is equal to d d theta of y over d d theta of x. And when I use polar coordinates, y is equal to r times sine theta, and x is equal to r times cosine of theta. And so taking the derivative, I would have use the product rule on top and the bottom. For the product rule on the top, I would have derivative of the first times the second plus the first times derivative of the second. And then on the denominator, same thing, I use the product rule, derivative of the first times the second plus the first times the derivative of the second, and minus because the derivative of cosine theta is negative sine theta. And so that is the formula for the slope of a tangent line to a polar curve that we derived in class. Okay, now let me plug in. R is equal to sine 2 theta, and so that means that dr d theta is equal to 2 times cosine of 2 theta. And so I plug in for r and plug in for dr d theta, and so I get dr d theta, so 2 times the cosine of 2 theta times the sine of theta, plus r, which is sine 2 theta, times the cosine of theta, all over dr d theta, so 2 cosine 2 theta again, times the cosine of theta, minus r, which is sine of 2 theta, times this extra sine of theta. And so that is the formula that I will use for this particular curve. Okay, now I plug in pi over 6. When I plug in pi over 6, I get dy dx is equal to, so 2 times the cosine of 2 times pi over 6 is pi over 3, times the sine of pi over 6. Then I have plus sine of pi over 3 again, because 2 times pi over 6 is pi over 3, times the cosine of pi over 6, all over 2 times the cosine of pi over 3 times the cosine of pi over 6 minus the sine of pi over 3 times the sine of pi over 6. Okay, now I just use my facts from trig identities to be able to, or my memorized trig values to be able to do this. So the cosine of pi over 3 is a half. Sine of pi over 6 is also a half. Square root of 3 over 2 is sine of pi over 3. Cosine of pi over 6 is the same thing, square root of 3 over 2. All over. On the bottom, I have 2 times a half times the square root of 3 over 2 minus sine of pi over 3 is square root of 3 over 2, and the sine of pi over 6 is 1/2. So on the top, I've got, if I put everything all over 4, on the top I have 2 plus 3 all over 4. So 2 times 1 times 1 is 2. Then square root of 3 times square root of 3 is 3, all over 2 times 2, which is 4. On the bottom, I have 2 times the square root of 3 over 4 minus the square root of 3 over 4. Now the over 4's cancel, and so I end up with 5 divided by the square root of 3. And so 5 divided by square root of 3 Or alternatively, if you wish to rationalize the denominator, 5 square root of 3 over 3, that is the slope of the tangent line when theta is equal to pi over 6.